In this lesson, we will learn how to factor polynomials of the form ax squared plus bx plus c. We've already learned how to factor polynomials like this when a is equal to 1, because then it just basically turns into the polynomial x squared plus bx plus c. But we know how to factor such a thing by finding the factor pairs of c whose sum is b. But what if the coefficient of x squared is not 1? Now, before we talk about factoring, let's go in the opposite direction. So let's try to multiply these two binomials together and see what trinomial we get, and see if we can find a relationship between the coefficients in the resulting trinomial and the coefficients in the two binomials along with their constant coefficients. So let's see what we get. Well, if I FOIL this product, I end up getting the following. Okay. Now, what I'm looking for is a relationship between this trinomial and the original product of two binomials. Okay. Notice that the product of the coefficients of the first term ends up being a, or my leading coefficient, right? Because the way I formed 6 squared in the first place was by FOILing, taking my first product, 2x times 3x gives me 6x squared. So the reason why this is helpful is because if I want to factor a polynomial of the form 6x squared plus something something something, I know that one possibility for my two leading coefficients in my binomials has to be factors of 6. Similarly, the sum of the coefficients of the outer and inner products, here's my outer product, here's my inner product, that ends up giving me my x term coefficient, which we call b. Okay, and also when I FOIL the product of the last terms, 5 times 2, ends up giving me 10. So you see, if I draw something here, you can it kind of makes things a little bit more clear. If I take 2x and 3x and I multiply them together, this ends up giving me 6x squared. Okay, and if I multiply 5 and 2 together, which is the product of my last terms, I end up getting 10. Okay, so if I have some kind of trinomial that has 6x squared and 10 as a constant, I know that one possibility is to have 2x plus 5 and 3x plus 2 multiplied together, because 2x times 3x give me 6x squared, and 5 times 2 ends up giving me 10. Okay, so in order to factor a polynomial of this form, I need to reverse the process of multiplication, so I need to go backwards. So what I do is I start by listing the possible factor pairs of a and c, and then I use trial and error to find a sum of b for the outer and inner products. You'll see what this looks like here in a second. So suppose I wanted to factor this trinomial here. Okay, well, there's a couple options. I know that my leading coefficient is 5. So I know that whatever these two numbers are here, they have to multiply together to give me 5, because that's how this term is formed. Similarly, I have a 2 here, but this 2 is formed by multiplying together the constants in my binomials. So these have to be factor pairs. This has to be a factor pair of 2. But since 5 and 2 are prime, I only have a couple options to consider. Okay, since 5 is a prime number, the only two integers that I multiply together to give me 5 are 1 and 5. Similarly, since 2 is a prime number, the only numbers I can multiply together are 1 and 2. So let's try this out. So let's try this. Let's try putting a 1 as the coefficient of n in my first binomial, and a 5 here as the coefficient of n in my second binomial. Notice now when I multiply these together, when I use FOIL, my first product is 1n times 5n, but that just gives me 5n squared, which is exactly what I wanted. Okay, and in order to get 2, I need to multiply some two numbers together, these two numbers here, whatever I'm going to put in order to get 2. But this is a prime number, so my only options are 1 and 2. So let's try this. Let's try putting a 1 here and a 2 here. Now let's check using FOIL if this product of two binomials is actually equal to the trinomial that I'm trying to factor. Well, I get 1n times 5n, which I know is going to be 5n squared. That's why I chose these coefficients to begin with. Okay, and I know my last constant term here is going to be resulting from the product of the last terms in my binomial, so 1 times 2 is 2. The only place where things might go wrong is with the middle term. So let's find out what my middle term is going to be. Well, my middle term is the result of adding together the inner and outer products. So if I have 1n times 2, this is my outer product, ends up being 2n. Okay, so let's say that in order to finish foiling, I already have my first product, my outer product. Now let's look at the inner product. 1 times 5n, this ends up giving me 5n. So I'm going to get a polynomial that has 2n and 5n in it together. So I need to combine like terms. 2n plus 5n is 7n, but I want 11n. Okay, I don't want I don't want 7n, so I got to try a different arrangement. Let's try putting the 2 here and the 1 over here and see if that'll work. Okay, so let's try this out. Let's keep the 1 here, the 5 here, because that's going to give me my 5n squared term with these 2 in red. And then before I had the 1 here and the 2 here, so let's reverse the roles there. Let's put a 2 here and a 1 here. I know that 1n and 5n is still going to give me 5n squared, and my constant term in my trinomial is a result of multiplying together my last terms in my 2 binomial. So 2 times 1 is still 2. However, watch what happens now when I form my outer product. I get 1n times 1, which is just 1n, and my inner product is 2 times 5n, which is 10n. So I end up with a trinomial where I have 1n plus 10n, but that just gives me 11n. So when I complete the multiplication here, I end up getting, okay, let's see, I end up getting that that 5n squared plus 11n plus 2 is actually equal to n plus 2 times 5n plus 1. Okay. Alright, now suppose I wanted to factor a trinomial like this. This is a little bit more complicated because now you notice that our coefficients here are no longer prime. I have a leading coefficient of 6 and a constant term of -8. So I have a few more options to look at now. Here are some things I can consider. The factor pairs of A, or the possibilities for my first terms here, are 1 and 6 and 2 and 3. And some factor pairs of C that I might consider are 1 and -8, 8 and -1, 2 and -4, 4 and -2, because all of these multiply together to give me -8. So all of these are possibilities for my last product. So let's try a few things out. Let's see. Okay, so let's first try maybe putting, let's try out these factor pairs of A first. So 1, 6. Let's maybe put the 1 here, put the 6 here. Okay, and then let's try putting a 1 and -8. Now, I don't even need to check that when I FOIL this, I'm going to get 6x squared and -8, because I chose these numbers so that that would happen. So, for example, I already know 1x times 6x, that's going to be 6x squared, and 1 times -8, that's -8. So the only two things I need to check are my outer product and my inner product. So I have 1x times -8, that gives me -8. Okay, and I have 1 times 6x, which is 6x. So notice when I add these two things together, I end up getting -8x plus 6x, which is -2x. So this does not look like it's going to work. Okay, so let's try some other things here. Let's keep the 1 and the 6. Let's keep the 1 and the 6 here. And let's try something different. Let's try the 2 and a -4. Okay. Once again, I don't need to check that I'm going to get my first term here, because I already know I chose these numbers so that that would happen. 1x times 6x, 6x squared, and 2 times -4 is -8. So once again, I only need to check my outer and inner products. let's see what I get here. I get 1 times negative 4, or 1x times negative 4x, or 1x times negative 4 is negative 4x. Okay, and then I get 2 times 6x, that's 12x. Okay, but notice when I add these two up, I don't get my negative 13x that I want. So let's try something else. Let's try the 2 and the 3. So let's try 2x here, 3x here, okay, and maybe positive 1 and negative 8. Okay, so once again, 2x times 3x, that's 6x squared, and I know that my last product's going to be 1 times negative 8, which is negative 8, so I don't need to check that. I just check my outer and inners. So I have 2x times negative 8, that gives me negative 16x, and 1 times 3x, that's just 3x. Notice here, I finally found what I wanted. Okay, I have that my x term, once I combine like terms, is going to be negative 16x plus 3x, but that's just negative 13x. So I actually got this one correct here with this configuration. Alright, so this is what I end up getting. That 5n squared plus 11n plus 2, if I want to completely factor it, I can factor it as 2x plus 1 times 3x minus 8. And of course you can check it. Okay, you can check it by using FOIL. So my first product is going to be 6x squared. My outer product is going to be 2x times negative 8. That's negative 16x. My inner product is 1 times 3x. That's just 3x. And of course 1 times negative 8. My last product is negative 8. So once I combine like terms here, I'd have 6x squared minus 13x minus 8, which is what I wanted. Okay. Alright, so the question that we answered today is, how do you factor trinomials of this form, ax squared plus bx plus c? Well, what you do is you find factor pairs for a and c, and you determine which arrangement of factor pairs will produce b, and it's basically just trial and error.